Okay guys, welcome back. This is part 3 of our relational mappings. In the last video, we completed the one-to-many relationship mapping, and we had to move a column from the owning table to the owned table. So now let's move on to the many-to-many relationship. Our example is the same, customers and addresses. So 2 customers can have the same address, but 2 addresses can also have the same customer. So this is what our tables used to look like. Once we're done, we will no longer need the customer ID in the address table, and to achieve this, we need to create a new table. This table is called a junction table, and the only purpose of this table is to map our relationship. It has no primary key column, although it does have a primary key that is a combination of the customer ID and the address, because you can imagine if it has the same customer ID and address, then it is a duplicate row. It allows for our relationship because if you look on the left-hand column, customer ID of 1 and then 1 again, map to 2 different addresses, 101 and 102. But you can have multiple addresses, 101 and 101, mapped to 2 different customers, 1 and 2. So this table is the key to allowing us to have a many-to-many relationship. Just like in the last video, we need to be careful about a certain step. So step 1, we're going to create a new table. Step 2, we're going to run a query that brings the existing data into the table. The customers have already defined their list of addresses. We don't want to come in later and say, that is no longer available. You're going to have to redo it, retype it in. That's really annoying. We want to keep their relationship, but then allow for a new mapping. Step 3, of course, we're going to test it, and then we can go back and delete our column on the address table, but only after we capture that data. Then we will need to update our classes. So we'll need to change the annotation from one-to-many to many-to-many. And instead of join column, we need to use the annotation at join table. We need to specify the table name. And then we need to add in the columns that we are joining on. So one column refers to the customer ID and the other column refers to the address ID. Then over on our address entity, we will also have to add a many-to-many annotation and a list of customers. However, when we do this, it does create a bidirectional relationship. This creates a circular reference, which will add issues later, but I will show you how to deal with it. So we have a lot of work to do. We need to add our new junction table. We need to run a query to uphold the relationship we already have. We need to update our annotations and then test. And then we can go back and delete our unnecessary column once we realize it is working. Okay, let's create our junction table first. So making our way over to MySQL Workbench, we need to run this query. So create table, customer address. Customer ID is a big int, as well as address ID is also a big int. Our primary key is a combination of both the customer ID and the address ID. So we don't have a specific column for the primary key. It's a combination of both columns. Our foreign key references our customer ID, and then another foreign key that references our address ID. Go ahead and run this, and we have a green check mark. Let's check to make sure it worked correctly. So describe customer underscore address. And we can see we have 2 fields, customer ID and address ID, which tells us it was generated correctly. So next up, we want to maintain the relationships we already have. We don't want to delete that data and make the customer re-enter it. So we're going to insert into customer address, customer ID, and address ID. We're going to select customer ID as address ID from the address table. So go ahead and run this. And then let's do a select star from our customer underscore address table. And look, we do have some data. So 1 to 1, 1 to 4, and 2 to 5. Now, off the top of my head, I can't remember if that is correct. So let's go into our other table to check to see if that matches up. And we have 1 to 1, 1 to 4, and 2 to 5. So this worked perfectly, meaning the data is still intact and the previous relationship can still be used. Okay, making our way back over to our project, we're going to start with our customer entity. We're going to delete this mapping of one-to-many and instead replace it with many-to-many. We're also going to delete the join column because we need to instead join table. And in this annotation, we need to specify a few things. So name is equal to customer underscore address. That's the name of our table. Join columns is equal to at join column, the name of our first column, which is customer ID. Inverse join columns, so at join column, name is equal to address ID. And we should have done this in the last video. Let's change this to addresses, not just address. Going over to our address entity, we can delete this customer ID. We no longer need it. So we're going to say at many to many, and it's going to be mapped by the addresses, private list of customers. So this is not something we had before. We now have a circular reference, meaning customers points to addresses and addresses point to customers. Let's go ahead and run this. And when we make our way over to Postman and ping this endpoint, customer/1, we get an error, could not get response. Why is this? Well, we have this giant error trace. Keep scrolling. It says cannot call send error after the response has been committed, but what's happening, it's trying to deal with the circular reference. So for example, if you're trying to send back a JSON response, it would look like this. Customer, and inside a customer you have an address, and inside an address you have a customer, and inside a customer you have an address, and this goes on forever because it keeps pointing back and ping-ponging back and forth. Now there are two ways to deal with this. So how to solve? We can either manage it with a DTO or data transfer object and avoid the circular reference, or for now we can just do a JSON ignore, which says, okay, when you're building the JSON response, just ignore this property, don't put it in the JSON. So that's what we'll do now, just for simplicity's sake. So at JSON ignore. We will rerun our application. Moving back over to Postman, we'll ping this endpoint again. And this time we got exactly what we expected. And pinging the other customer's endpoint, we also get the correct data. Okay, now that we've verified that it is working and that we moved our data over from the previous column into our new table, let's go ahead and clean up our old data. So we no longer need the customer ID column from the address table, but before we can drop it, we must also drop the foreign key constraint. So alter table address, drop foreign key, we named it fk_customer, and then we can alter table address, drop column, customer ID. Go ahead and run this. We get a green check mark, and we can verify. Let's do a select star on the address table. And we are no longer getting the column ID back from our query, which means it has been deleted successfully. Okay, that completes our mini series on relational mappings. We covered one-to-one, we covered one-to-many, and in today's episode we covered many-to-many. Thank you for joining us. On to the next video.